Hello again, and we're going to be talking about inverse functions on this video. I've got 3 examples of inverse functions on the board. An inverse function is the function that is symmetric around the oblique asymptote or the 45-degree angle. As you can see, the 45-degree angle is the green dotted line. I don't have it on this one, but you can see that it is, hold on just a second, I'm going to draw a green line right there, and you can see, I can't dot it, but you can see that it is symmetrical. Now, it's pretty simple to find or to see the inverse on the graph, but how do you find the inverse algebraically? Well, it's pretty simple. I just wanted to put the graphs up there so you could see what the actual inverse shows us. And the inverse shows us the flip side of a 45-degree angle. But how do you find it? Well, in this case, f of x is equal to 2x plus 1. F of x is equal to 2x plus 1. I'm going to do that in blue since it has a blue curve or line there. I'm going to do and change f of x to y. Then interchange x and y. And that will give us x is equal to 2y plus 1. And now solve for y. Minus 1, minus 1. And now it turns to red. X minus 1 is equal to 2y divided by 2. So now y inverse is equal to x minus 1 over 2. And that is the graph of the red line. Now again, how did you do that? 1. You put in y for f of x. That's the first thing you do. Put in y for f of x. Then you switch. I don't know why this thing don't want to write on the left side of the board. Switch x and y and solve for y. And when you solve for y, you saw I switched colors and also put a y to the negative 1 here, because that means the y to the negative 1, that means the inverse of y. Okay, so let's do the next one. I'll start in blue. And that's going to give me f of x. Well, I'm not writing in lines, Hubert. F of x is equal to x squared, and that means y is equal to x squared. Switch x is equal to y squared, and solve for, and then I'm going to turn it to red, excuse me. So y inverse is equal to the square root of x. Now I want to make a note in here. You can't take the square root of a negative number. So I want to make sure you understand that, because technically this is the only part of the function that is real. Okay? That solid line. So I just wanted to, took the square root of x, you get positive or negative 1. You can't take the square root. Well, yeah, you could. That'll give us the inverse. I'm sorry. And you see that it's symmetrical around the 45-degree angle. Now, of course, here you have y f of x. Let me get my blue. F of x is equal to 2 to the x. Y is equal to the x. Switch them. X is equal to the y. Well, in order to do this problem, I have to take the log of both sides, or I can use the definition of a logarithm. We'll use the definition of a logarithm, and the definition of a logarithm that we just went over says if I give log base a of x is equal to y, that will give me a to the y is equal to x. Well, I've got a to the y is equal to x right here. So if I've got a to the y, then I'm going to have log base 2 is equal to x. Or log base 2 of x is equal to y, sorry. Log base 2 of x, and I need to write this in red. So y inverse is equal to log base 2 of x. I think that should be the answer. That is what we learned in the last, taking the definition of a logarithm, and that is the red function right there. So anytime you're given a function, you can find the inverse by changing the f of x to a y, then switching the x and the y, and then solving for y. And when you solve for that y, you're going to put a little -1 there, and then that's going to be equal to square root of x, or whatever the case may be. And that's how you find the inverse of a function algebraically.